Hello everyone and welcome to our first video about Introduction to Pilot Data Analysis. So data analysis is a very crucial step in water treatment research, especially using pilot plant, because it can guide us for our future research, also for scaling up process, and also it can help us to optimize the process and also it can increase the efficiency of the water treatment process. In this video, actually, we are going to use data analysis to see what parameters or factors that can affect pressure drop in a water treatment pilot plant using membrane technology. To conduct this analysis, actually, I have generated a synthetic data that can stimulate or can simulate the operation conditions of our pilot plant. So the main objective of this data analysis is to see the relationships between operation conditions and parameters in our data and pressure drop. Because as most of you know that pressure drop is very important aspect in membrane technology for water treatment. So in this video, we'll use various statistical techniques and visualization to uncover insights on these relationships between pressure drop and other parameters or factors in our data. So let's get started with data analysis. In order to perform data analysis in Python, you have to import different libraries. The libraries that you are going to use for your data analysis process. In our case, we will use pandas for data manipulation and analysis, and we will use numpy for numerical operations. Also for data manipulation and analysis, we will use cboard. And finally, for data visualization, we will use matplotlib. So let's run this cell. The second step in our process is to do data pre-processing. First of all, let's read our data file. And we will use pandas for this. The second thing is to check how many rows and columns in our data. So as you can see, we have 20,000 rows and 9 columns. Let's see what are those columns in our data. We will use something called data head, and this will show you like 5 rows of your data. As you can see, we have feed flow rate, we have feed salinity in gram per liter, we have also recovery, and we have our main targeted parameter, which is pressure drop in bar. The most important step in this process is to see if we have a missing values in our data or not. Let's see that by running a cell with data is null sum. As you can see, we don't have any missing values in our columns. So each column here has like a zero, which indicates that we don't have a missing values. One important thing in data pre-processing is to see like statistics of our data or summary of that. Let's see. So data describe give you like an overview of statistics of your data. So it gives us like mean and minimum and standard deviation and maximum. Let's take feed salinity. So the mean value of feed salinity in our data, it's like around 37 gram per liter, while the maximum value is around 70 gram per liter. Let's go for our targeted parameter pressure drop. So the minimum value is around 0.7, while the maximum value is 7.4, and the mean pressure drop in our data is around 4 bar. So now let's start with our EDA. So our main objective to see the correlation between pressure drop, our main targeted value, and other parameters in our data. In order to do that, we will use something in Python called correlation matrix. So correlation matrix actually is a very nice visualization that can tell you the correlation between parameters in your data. In our case, we wanted to see what are factors or parameters that can affect pressure drop, or in other words, the correlation between pressure drop and other parameters in our data. Let's take a look about feed flow rate. So between pressure drop here in y-axis and in x and feed flow rate in x-axis, we can see the correlation number. In this case, it's a negative number that shows like there is no any correlation. While for feed TDS, we have like positive number, which is 0.5, that shows like somehow a correlation between feed TDS and pressure drop. While here, we can see like this is a high correlation or maximum correlation between feed salinity and pressure drop, which actually in real scenario or real case, this is not correct. But because we have a synthetic data, so we can see this correlation. Also, we have correlation between permeate, TDS, and pressure drop. While for other like recovery and flux, almost there is no any correlation. So after that, we will go to explore our like the distribution of pressure drop. So it's well distributed actually, and as we discussed before or mentioned before, the mean value of pressure drop is around 4. Let's go also to see the positive parameters like or parameters that have a positive correlation with pressure drop. First of all, TDS somehow also distributed between 500 ppm and 1000 ppm. Let's go for feed salinity. So also it's well distributed, and we have like a maximum value of around 70, while the mean value is around 40. Now let's also explore the correlation or the relationship between pressure drop and other parameters, and we will do that with nice graph called like scatter plots. So as you can see here, the relationship between pressure drop and y-axis and other parameters. As we mentioned, there is no correlation between feed flow rate and pressure drop, as you can see. While for feed TDS, you can see somehow a positive correlation. Increase with increasing feed TDS, we have a increase in pressure drop. And for feed salinity, we have a linear correlation or linear relationship, which like as we mentioned before is around 1 in correlation matrix. So it's very correlated to pressure drop. When we have an increase in feed salinity, we will have an increased pressure drop. This is logical, but in real case, this high correlation is not that correct. While also for flux and other parameters, there is no correlation. The last thing to see also the correlation with numerical features, we will use other correlation bar plot to see the correlation. As we mentioned before, the correlation with pressure drop with feed salinity is around 1, for feed TDS is around 0.5, and for permeate TDS around 0.2. There is also a very important test called ANOVA test, analysis of variance, that can see you like if there is like the correlation is significantly statistical or not, and we will do that in other videos with other also data analysis. Maybe we will use machine learning. So see you in next video.